All right, so we'll have a quiz, but of course, first before we go over the quiz, I like to make sure that we go over the material that from last week, or at least address any questions that you might have about big O notation, right? So let's start there with what questions do people have about big O notation before we start taking a quiz? Right. So most of the time you're dealing with things that are along the lines of constant time, linear time, or quadratic time. Almost all, except for a few circumstances which you can pretty much identify right away, which are out there. Those are the times you're going to be dealing with in this class. Constant time, linear time, and quadratic time. So let's go ahead and say, for example, basically that I've got, let's see. Oh, right, I haven't gotten this attached. All right, so suppose you've got the contains method from the array list, right? What does the contains method do, anybody? What does the contains method do for a list? This should be fairly straightforward. It's not a trick question. Yes? Sorry? Yeah, it returns a Boolean. And what does it return? Yeah, it returns true or false, but I mean, what does it tell you? Yes? It tells you if an element is in the list. So if an element is in the list, it returns true. If it's not in the list, it returns false. So how does it go about doing that? How does it go about doing that precisely?
For loops through every item in the list.
Yeah, it looks through every single item in the list, uses a for loop to do that. So what would the runtime of the contains method be? Yes? It would be O of n because it checks because worst case scenario, it has to check all n items in the list. So it's a fairly straightforward thing there, right? What about for an array list, the set method, right? What if you want to change, not insert something, but change something in an array list, right? What's the runtime for the set method? Anyone? Or yes, it's constant time, right? And let me go ahead and I think I should be able to pull that up fairly easily. Yeah, it's a constant time algorithm, right? If we go to our code, go to data structures, go to array lists, my array list, right? We look at this and it says, hey, here is the, let's see, that's the add, there's reallocate, there's set over here, which does a simple check, right? That says, hey, if index is less than 0 or if it's greater than or equal to size, then we throw an exception, right? Otherwise, we just grab the old item so we can return it. We replace the item at a particular index. Again, these are constant time operations because just manipulating, all we're doing is storing memory locations inside variables at this point, right? There's no for loop involved here, right? We don't actually have to go and manually find the index, right? We can just jump to the index automatically because that's the way arrays work. It's completely opposite in the linked list videos, as you'll see, right, where you actually have to go and manually walk your way from index 0 to the appropriate node in the linked list. But here it takes constant time. All right. Similarly, what about the add method? What is the worst case scenario for the add method? How long does that take? Adding an item. I heard it. Yeah, O of n. And why is that? Because there's a lot of scenarios in it that can take O of n, and all of them would be correct, right, for worst case scenario. So adding an item to the beginning of the list, how long is that going to take? That's going to take O of n time. Why? Because when you add an item to the array list and its space is taken up, you have to shift things over, right? So adding it to the beginning of an array list means you have to shift n items over, right? Makes sense. If you're inserting in the middle, you have to shift n over 2 items, which means you have to shift over half the items in the list. That's still a linear relationship going on there. If you're adding it to the end, right, you have to, basically that can be a constant time operation because you're not necessarily going to shift anything, but it could also be an O of n operation if the size is equal to the capacity, in which case we would have to reallocate, right? We'd have to reallocate on the worst case if we're adding a single item. However, we kind of just ignore that if we're just adding a whole lot of items is kind of the idea with the amortization, but that's goes above and beyond what I need you to know. Now, the reason I'm going over the add method specifically is because that, as I mentioned in the video, I always have a 20-point question on the exam. Okay, it's always a 20-point question on the exam, right? And it says, all right, array lists and linked lists, they function very differently, but they're both valid implementations for a list. Please compare and contrast, how they operate, right? So like compare and contrast them to show where they perform better in some operations and worse in some operations, right? So you want to compare and contrast how they do add and what the costs are for add and other methods, right? So that's worth 20 points, and I go over it and I've gone over it in the very last video that I posted for this thing, which brings me to the point that next week will most likely be your exam. I don't see any reason to delay that. We've got plenty of content for that, and it will be going over linked list. Similarly, the homework, which I will go over after the quiz, that goes over linked lists, and I have given you a very generous due date on that. Worst case scenario, I can always throw together, if I find that you guys are actually really awesome and most of the class has it done, I can always throw together, I have another linked list assignment that I wanted to write up but didn't have the time to write up, but I can always write it up like tomorrow as an extra credit assignment for you guys, or for people who just look at that and say, hey, could I have something a bit more interesting? So I put the due date not next week, like not a week from now, but actually at the end of the week, next week. So Friday the 28th, when you guys would have most of your after your exams are done. Now that being said, do it before the exam, right? Or do the vast majority of it before the exam, because it's really good practice for doing what you need to do on the exam, right? If the exam has to deal with a lot of coding with a linked list, then that's it. Then it will be very useful. The other big thing to note is that I should be giving you your practice exam by the 20th. Okay. That way you'll have a week to work on the practice exam, and then I'll have the answers, and I'll either do a practice exam review here, most likely here rather than on a video. Okay. So this quiz will be on Big O notation. It shouldn't be too hard. It's 20 points, 6 of which you should get for free, right? So a couple of the questions, 2 of the questions deal with analyzing array list code, right? And should be very, very familiar, but I post the code for you guys so you guys can analyze it in case you don't know what the methods would do, right? I have the code on there. And then I just ask you other things. But again, most of the questions, it will be 1 of 3. Constant time. Does it do, okay? So remember, constant time. Constant time means it doesn't care about how big the list is. It will do the same operations no matter what. Linear time means it cares how big the list is, and it will do a linear amount. There will be a linear relationship between the amount of steps it needs to operate on and the amount of time it's going to take, right? And a quadratic relationship means that basically, if I have to do one more item worth of work, right, if I add one more item, that means that actually I'm adding a whole lot more work for everybody. That impacts the amount of work that you have to do on everything. All right, so with that, the quiz, we'll start the quiz.